Hi everybody, it's Tyler here at Vex Rolls. I'm checking in with 17711E Entropy, coming in from the UK, who's been having a phenomenal season so far. And we got Bianca here to talk more about this robot. This is a phenomenal machine. We're going to be focusing a lot more on the software side of things on this robot. A few things in terms of hardware, but there's a lot of great things as well too. From this awesome 3D printed field over here we'll be talking about to a lot of cool stuff I can't wait to dive more into with Entropy coming up here on Pits and Parts. Bianca, let's start to dive more into this robot here. You got a lot of great different attributes on this. One of the things we talked about earlier is this double line this line sensor, and you got a double IMU as well too. Talk to me more about it.
Yeah, so one of the most useful features on my robot that I've been using all of Vex Worlds is the double infrared sensor in the form of sort of the Vex line sensor that's not used as often on the front of the drive base. So you can see I've got two here, and it's inspired by first LEGO League robots, the way they square up to lines, and sort of if one side of the drivetrain is off, it goes and aligns and is parallel with that line. This is really useful in skills because then you can adjust the robot and figure out the exact position and orientation of the robot on the field. It's also got the secondary advantage of during matches, you don't want to be crossing that middle autonomous line. So in order to not cross that middle autonomous line, you can detect the difference in reflected light intensity from the field tiles. This way, if the robot is crossing the auton line, it knows, I gotta stop moving, and it stops and cuts the auton. In addition to this precision gathering stuff, we have a double IMU on the bottom. So this is done using a custom class within our code base. This custom IMU takes the geometric mean. However, this is inaccurate because if one of the IMUs drifts, it won't result in an accurate measure.
And looking at from that drift in a match on there too, we've talked to a lot of teams who are using odometry or just using encoders and stuff like that. What made you want to choose a double IMU?
A double IMU sort of adds more precision because an issue I had in early season was that the IMU drifts. If it's an old IMU, it will give more and more inaccurate positions and readings over time. So if you account for that in your code and detect, oh, one of my IMUs is drifting, then I know, okay, stop reading data from that, just take the result from the other IMU.
Some of the other cool things on this is tip the robot back up here, and one of the things we talked about earlier is that you were trying to go with a tier 3 climb for this, but had to abandon that climb. There's kind of a cool story behind that, so I'd love to hear just more about how that process went for you leading in the Vex Worlds.
Oh, the tier 3. That was an interesting engineering challenge. As you can see, I've got the remnants of the passive hooks here on the back of the robot that would slide up and hook the robot onto each rung of the ladder. The tier 3 design that I had for our regional championships, national championships, I had 2 linear slides on the back of the robot that are sort of, if you know FRC robots, it's that FRC classic climb mechanism. But linear slides are really annoying to build with Vex parts. These C-channels have loads of friction. So I went with sort of the more Vexy 2-bar linkage that would be pistonized upwards, winch back down and pull the robot up. This worked decently well. It could get up to the second or maybe even third rung, but the main issue with this was, what if the robot fell? It fell multiple times, flat on its face, so bam, the intake broke, and it takes ages to fix because I built a lot of this robot using nylon screws and it's designed to be light, so I didn't want to take that risk at Worlds. If the robot falls, that is the end of my World Championships.
A couple other things I want to highlight on this here. You have something called a drive tracer, so I'd love to hear more about that. But you also were planning to put a GPS on your robot as well too. I know it didn't quite make it on, but can you just talk to me a little bit more about what we were planning on doing for that?
One of the coolest code features I developed was drive tracer. So when you're developing autons, you think, okay, this is awkward to do, or I'm not sure what the path even looks like. You may use sort of online tools to visualize that, but really the best way to see if an auton is going to work is just by driving it with the controller yourself. So what Drive Tracer does is it logs all the controller inputs every 20 milliseconds, saves that to a JSON file on the V5 brain in an SD card, and then I can use that data to replay the robot movements, just feeding it back in the form of an autonomous routine. This was the first version of Drive Tracer, but the issue with it was that while it's time accurate, it knows when to stop the auton at the right time because it's just emulating your driver inputs. It's not positionally accurate because the robot never knew where it was in the first place. The second version of Drive Tracer stored extra data. It stored X, Y, and theta, so it knew where the robot is on the field at all points in time. This meant I could go into Matplotlib, plot the whole route that the robot took during driver, and then use a line simplification algorithm to determine waypoints and make my Auton as I would normally using whatever software you want to use.
Is there anywhere that teams might be able to find more information about Drive Tracer at all if they want to learn more about it?
I'm actually continuing to work on Drive Tracer even after the end of the high stakes season, and I am looking to publish it on my GitHub in due course.
Very cool. So keep an eye out for that as you go through. And we kind of alluded a little bit before, you're planning on putting a GPS on your robot. Do you mind just covering a little bit about that?
Yeah, so I actually had a GPS on my previous robot design. It was mounted on the back here, and it wasn't for localization. GPS sensors are known to be buggy and unreliable, and no one in Vex likes them. But the reason I was using the GPS is to eliminate human error in the drive chain, especially because there's only one of me in the drive team. If one thing goes wrong, there's no one to say, oh, Bianca, fix that. So the GPS sensor determined, yes, I know I am in this quadrant of the field, and it's checking that the Auton you've selected in our Auton selector, that the Auton selected in the Auton selector is correct and valid for this quadrant of the field, or if it's going to cross the autonomous line, because of course you don't want to be doing that.
Yeah, okay, you have multiple championships this year so far, plus a couple excellence awards as well too. Talk to me, what is it like being on a solo team and be on this team yourself? Like, I can't imagine trying to compact everything you do into what you do yourself. So just talk to me more about what that process is like.
It's difficult because it's not only the building of the robot and programming the robot, it's also that really massive document called the engineering notebook that takes a lot of your time. It eats up time, and sort of competition-wise, it's difficult because all of World Championships, I've been walking to and from divisions with my robot box, battery, air pump, controller, and it's difficult to carry that sort of on your own. From a management perspective, maybe solo could be better because, you don't need to rely on teammates, but I think having people to work with you and sort of collaborate on the design is always going to be better than sort of, this is my robot.
And I think one of the things for you too, I'm sure you've been able to collaborate with other people all around Vex as well too, so there's a great opportunity for that as well. One thing I want to wrap up with, this is really cool by the way, this 3D printed field that you have. I think one of the things when you were talking about earlier that really impressed me is it's not just a 3D printed field, but it can be utilized for a lot of great things. So talk to me about a couple of those things.
So, to begin with, this 3D printed field took 50 hours of 3D printing, and I have an X1 Carbon, so this was a struggle. And another cool thing to mention about this field is that the GPS code strips are fully accurate to the actual strips on the field, even accounting for sort of the irregularities in the game manual in the early season. So the reason I printed this field is game strategy. It's way nicer to have a physical field that you can score rings on, say, yeah, I'm going to get a top stake in the finals match, and sort of strategize with your alliance partners than just having sort of a whiteboard and laying things out. And it's interactive. It gets people to come to your pit, and it gets people to sort of come talk to me. I want to get to know more people in Vex.
Absolutely. Well, Bianca, first off, thank you so much for taking time to talk about this. Congratulations on the success you have and Entropy has had as well too. And can't wait to see, hopefully as we get into the playoffs tomorrow, we'll see how everything winds up. I know you got high expectations and we can't wait to see how you do. Thanks a lot.
Thank you so much for having me.